Hello again. Let's tackle genetics problem set number 4, the dihybrid cross problems. So these are going to follow the same format that we've used earlier, how we handle the problem, how we handle the procedure, and we dissect the problems and then set up the alleles and draw your squares. It's just twice as big. All right, so it says in guinea pigs. In guinea pigs, the black coat color, big B, is dominant to the white color, coat color, little b. And that rough coat is dominant to smooth. All right, so we're dealing with two characteristics here. We're dealing with coat color and coat texture, okay? We're dealing with black and white, rough and smooth. Then it says a heterozygous black, so we have a heterozygous black and heterozygous rough. So there's your dihybrid cross right there, your two characteristics, the guinea pig's coat color and the guinea pig's coat texture. So you have a male that is heterozygous black and heterozygous rough, and he is crossed with a female who is also heterozygous black and heterozygous rough. So then determine the following. We can do this. So now that we've read through the problem and dissected the problem, let's list our alleles, define our alleles, and then figure out which alleles the parents offer to their offspring. So it gave us big B and little b, like such. And it said that in guinea pigs, black coat color is dominant. So this is a black coat. And that white coat is recessive. Cool. Then it told us, gave us some R's. And it told us that in guinea pigs, a rough coat is dominant to a smooth coat. And again, all of these genetics problems are real. We've gone to great extent to look this up and make sure that everything here is real. So there's our first step. So, and we draw our parents, we draw our cross, right? So draw yourself a guinea pig. There's the male. And here's the female. I can't wait to see your drawings of your guinea pigs. And so the problem tells us, let's take a look at the male first. The problem tells us that the male is heterozygous black and heterozygous rough. So heterozygote, if he's heterozygous, that means his alleles are different. He has one dominant and one recessive. So if he is heterozygous black, he is big B, little b, because he's a heterozygote. Then the problem tells us that he is heterozygous rough for his coat texture, how it feels. Well, if he's heterozygous rough, he is big R, little r. That is heterozygous black, heterozygous rough. And there's your male. And then it says this male is crossed with a female, and the female has the same genotype. The female is also heterozygous black and heterozygous rough. So she is also heterozygous black and heterozygous rough. So step 1 is always to read the problem. Step 2, we defined our alleles. And step 3, define your cross. Again, see these problems as procedure. And as the organisms change, no worries. Now we need to decide what pairs of alleles do these parents offer their offspring. And this is where, just like in your Cornell notes, you distribute as if we were in math. So you distribute the B's, the dominant B, like such. So that would be big B to big R. And then it would be big B to little r. So now that we've distributed the dominant B, now we distribute the recessive B. Now don't forget these are written alphabetically first. So little b to the big R, and little b to the little r. These are your 4 possible combinations with a parent that has this genotype. Now, the nice thing about this problem is the female and the male have the same genotype. So they're offering the same alleles to their offspring. Big B, big R, big B, little r, like such. And then distribute the little b just like we did earlier. Again, write them alphabetically. Little b, big R, little b, little r. And so there's your fourth step. Dissect the problem, define your alleles, set up your cross, and now with the dihybrid cross, you have to establish what alleles are offered to the offspring. Okay, so now that we know what the parents are offering, it's time to draw the Punnett square. Here's the cool part. It's a 4x4, okay? And you say, well, it's a 4x4. Yes. See these 4 combinations that the female offers? We're going to put her big B, big R, big B, little r, little b, big R, and little b, little r. We're going to put these 4 right across the top here. So the female offers her offspring big B, big R, big B, little r, little b, big R, and little b, little r. So these 4 are what she offers her offspring here. And then the same is true for the male. So the male offers these 4 to his offspring. So we're going to take these 4 and simply put them on the other side of the Punnett square. So here's the male's contribution to the offspring. Here's the female's contribution. So now, just like in the 2x2 Punnett square, this is what he offers in his sperm. This is what she offers in her ovum. When these 2 gametes join by the process of fertilization, you get big B, big R, big R. And now the offspring carries 2 alleles, a homologous pair for coat color and a homologous pair for coat texture. So now this and this. Big B, big R, little r for those 2. And now this one with this one. Big B, little b, big R, big R. Notice how I am writing them alphabetically first, and then when you do the B's, of course, the dominant B goes first. Like such. So this allele combination from dad with these 4 allele combinations from mom. Now I take this allele pair, this one first from mom, big B, big R, little r, big B, little r, big B, little b, big R, little r, big B, little r, little r. The most important thing to remember on a dihybrid cross is to take your time. There's no shortcut. There's no way to do it faster. You just take your time and go through it one by one. And now we'll do the last 4. There's nothing new here. These are the same rules, the same guidelines that we did earlier, just in a larger format. All right, now in a dihybrid cross, we will never ask you for genotype. There's too many. But we will ask you for the phenotypic ratio, okay? So there's 4 choices. And you say, well, how do I know what 4? You go back to when you defined your alleles. Excuse me. The first choice is black. okay, because this is the dominant condition. So the offspring could be black, but there's two choices for what could go with the black fur. It could be black here, it could be black with rough, or it could be black with smooth. You write the rough first because the problem told us that rough is dominant. So you have black, black, so you have black rough, and then black smooth. You then write your recessive condition. Well, if black is dominant, then white was recessive, or is recessive. Well, what are the two choices that can go along with white? Well, you always write the dominant first for texture. White rough, and white smooth. You say, well, how did you know those four? You go back to here. Your first choice here, because it's alphabetical, so that it could be black rough or black smooth. And then your second choice would be white, because it's recessive. And then you go white rough, white smooth. So here's your four combinations. Now, at this point, this is bookkeeping. So what you do is you just take it one by one. So any organism that carries a big B is black, and any organism that carries a big R is rough. So this one, black, rough. Check it off and go down here and make a tick mark. Second one, black, rough. Check mark, tick mark. Black, rough. And hey, what do you know? Black and rough. So all four in that first row are black and rough. These little check marks are really important because we have 4 and 4. It's easy to get lost here if you hurry. Take your time, there's no rush. So, second row, also black and rough. Black, smooth, 2 lowercase r. That is black smooth over here. Black and rough. And now black and smooth. So now we have 4, 8 check marks, 5, 6, 7, 8 tick marks. Excellent, 8 and 8. Third row, black and rough, black and rough, white and rough. So this is white and rough here, white and rough again. Excuse me. So then here, black and rough, black and smooth, white and rough, white and smooth. So this one should not be here. Okay, so we have 4, 8, 12, 16 boxes. Let's be sure that we have 16 tick marks. 5, 9, 10, 11, 12, 13, 14, 15, 16. So our ratio is 9 to 3 to 3 to 1. And always you go back to the problem, make sure that we answered all of the parts of the problem. So it says, what's the phenotypic ratio of their offspring? We got it, 9 to 3 to 3 to 1. But then part B says, what's the probability of them having a white rough? White rough, come back here, and let's see, white rough, here, 3. 3 out of how many different possibilities? 16. That's your percentage. So I would grab your phone, find the calculator on that, divide 3 by 16, and that will give you the percent or the probability of this pair having a white rough offspring. So don't be intimidated by the length of these problems. Take it step by step, work your way through it. And if you have any questions, let me know.